Welcome to the Heartland Journals podcast with your host, Steve Abramowitz, editor-in-chief of heartlandjournal.com.
Howdy, y'all. Welcome back to the show. I'm Steve Abramowitz, and this is the heartlandjournal.com podcast. If you like what you hear, please subscribe and pass it all around. We only grow with your help. Thanks for doing it. And I have a feeling with this show, you're going to want to do that 10 times fold. On this show, we are focusing on our nation today with always an interesting person making a positive change in our community, where I interview people who are making an impact and are lovers of truth. Today, we are talking with a very special guest, Dr. Robert Malone, physician, inventor, scientist, author, speaker, bioethicist, journalist, and the Malone Institute. The Malone Institute, his mission is to bring back integrity to government, the biological sciences, and medicine. They also support and conduct research and education in health and wellness. His book, Psy-War, Enforcing the New World Order, is out now wherever you buy your books these days. And Lies My Government Told Me and The Better Future Coming, I see it $9.99 on Kindle. Check them both out. Dr. Malone, what a thrill to have you on. How are you today?
Good. Just back from feeding the horses. I still got some mares to go, so they're getting a little bit frisky in the back. But it's a lovely day here in Madison, Virginia.
I didn't mention gentleman farmer in your intro. Sorry about that, but you did it for me, so thank you. You said Virginia. Okay, so take us back to the good old days before your work with mRNA and pre-COVID. What were you doing in your career?
Well, all of that happened when I was 28, so I can't really. Career would be a overstatement. I grew up in the Central Coast of California, son of an engineer and a teacher in the town of Goleta, California, which is just north of Santa Barbara, right along the coast. If any of you have watched the Dennis Quaid Reagan movie and seen the final scenes where he's riding in the hills overlooking the ocean, that's where I grew up. And that's where my wife and I used to go riding all the time. His farm was about 4 to 5 miles as a crow flies from my home as a young person in junior high and high school.
Awesome. And I'm from California, and my business partner wrote the movie Reagan. So yes, we know exactly what that scene was like and what you lived in.
Okay, very good. So I intuitively called that correctly. Yeah, kind of a special place and a special point in time that is gone now. Yeah. The bluffs and cliffs and beach along that we used to ride, in addition to back in the hills, is all gone now. It's the Bacaro Resort. And you no longer have dead seals and globs of oil and bits of kelp along the coast. It's all groomed and proper, and it's where people like Oprah Winfrey have their condos, etc.
And before the Pacific Palisades fire, there was a huge fire that almost got the Reagan Ranch. So, yeah,
Well, that's part of why my parents and my in-laws both moved out of that area and up the coast to Napomo because they were, growing up with wildfires is, you can't, wildfires and earthquakes, but wildfires are a lot more threatening than the earthquakes are in many ways.
Much more unpredictable too. Yeah. I'm from the Bay Area, Napa, California. And so we would always have the smoke just settle in the valley, and it was terrible.
Absolutely. So you get it.
Yeah.
Yeah. So, a lot of empathy for the folks that have just been subjected to this in the Palisades and along Malibu. You cannot convey how terrifying it is to have the roar of the wall of fire coming at you, and the smoke and chaos and confusion, and especially if you're somebody that has animals, horses or otherwise. You have the burden of responsibility of how to mitigate the risk for them. When my wife and I, when we were young, we had a young Arab that had to get evacuated in one of those wildfires, and
especially at night, right, where it's almost like a hellscape.
Hey, I'm on the podcast. Okay, bye.
Hopefully that wasn't Donald Trump or something like that.
No, that was my wife. More important than Donald Trump.
Oh,
Uh,
yes, of course.
yeah, so a lot of empathy for those, I never forget the frantic of where have they taken our horse and what have they done with it and is it okay? And it's a horrible, horrible situation. Wildfires are.
Yeah.
Yeah,
So what?
so now we live in Virginia, and um, we did have a wildfire kind of here. We're up against the Shenandoah National Park, and we had a little fire break out last year. And as an ex-Californian expat, I watched that thing, and I'm like, they need to get on that.
It would help if they filled the reservoirs a year ahead of time, wouldn't it? Yeah.
And they and they
Virginia
just
knows about that, I
they
believe.
just let it burn, and they thought it'd burn its way out. I'm like, no, that is not going to go. And it ended up being for the locals, it was a big deal.
Yeah. Yeah.
Nothing in the context of these wildfires in California, but
Very similar to Sonoma, California, like I said, where I was back then. So, all right. So moving on, what was the problem that you were trying to solve with
oh yeah,
mRNA?
so so
Did the
uh,
world need it?
so the history, I got sidetracked. So grew
All
up
right.
there, and I was literally a avocado farmhand, and a carpenter. And in 19 New Year's Eve, 1980, we won't go into the context of why I had an epiphany, but I had an epiphany that I really didn't want to live that way anymore. I wanted to be able to take care of my wife. I wanted to make something of myself. And so I enrolled in Santa Barbara Community College, and which was one of the better junior colleges really in the United States at the time. It's gone all woke now. And much to my surprise, I hadn't destroyed my brain with my ill-fated lifestyle in the Central Coast there. And I got straight A's. And that kind of launched me. I went from there to UC Davis and focused on biochemistry, molecular biology, and I became a total lab bench rat in a laboratory that, uh, among other things, ended up being at the very forefront of the initial investigations in the origin of AIDS, and also work in breast cancer both with retroviruses. So I became basically a retrovirus expert as a young person. And then the question was, well, what do you do with that? And I worked so hard and I did so well that I got a scholarship for an MD PhD program at Northwestern in Chicago. The consequence of which is my wife will never allow me to make a decision about relocation again. Uh, and because Chicago does get a little cold. And so I really wanted to be a pediatric gene therapist and treat inborn errors in metabolism. I thought this was going to be the future, and it was going to be retroviruses. And they just didn't have the level of talent in those kinds of areas at Northwestern. And they absolutely did at UC San Diego in the Salk Institute. They had the top gene therapy labs in the world. And I nailed my GREs. I was like off the charts, my graduate exams after 2 years of medical school, plus what I'd done at Davis. So I got in, easy to UC San Diego, and we moved down there, lived in student housing. And that's where I did the work in this gene therapy lab focused on packaging RNA into retroviruses, which is a core problem in the field. And that is what led me to develop a method for large-scale manufacturing of mRNA, purifying away from DNA fragments, the structure of the RNA necessary to get it made into proteins, and then the solving the problem of how to get it delivered into cells and tissues. And that's a kind of a long, convoluted story
Well,
that
can you describe the moment you first realized the potential of mRNA as a tool for medical applications? What inspired the breakthrough?
so what happened was that these series of discoveries and inventions uh, led me to filing an invention disclosure that you could use mRNA as a drug. That was the epiphany initially, was I'm working in a viral vector lab, and I'm way out on the edge in the gene therapy space. I'm focused on non-viral gene therapy. That's heresy. And if that isn't bad enough, I'm now focused on using mRNA as a drug, which was just way, way outside of the paradigm. Uh, and um, and one of the things that happened at that time that was really heretical, not only to be working with RNA and thinking of it as a gene therapy kind of gene therapy light, because one of the problems with gene therapy is that once you administer the medicine to the patient, you can no longer control the dose because it's producing the protein. The patient is the manufacturing facility. And if something goes wrong, if there's something that's causing sickness, adverse events in the recipient, you can't go in and surgically cut it out. It's all over the body. And as if that isn't bad enough, the other problem, see, and so for me, this is like I'm passionately working as a late 20-something to try to enable this future and this technology. And I'm realizing that it is fundamentally flawed. And it's never going to come to pass. And in fact, that turns out to have been correct for the most part.
It's like discovering the atom can be split, realizing, wait a minute, I shouldn't have done that.
Yeah. Or it's not going to work out so well.
In the wrong hands, right? Yeah, exactly.
Right, which everything always falls into the wrong hands. That's what you can predict. If there's one thing you can be sure of, is that if a new invention can be weaponized, it will be.
Yeah, that variable is constant. Yeah.
Yeah. So the other epiphany was the postdoc that I was working next to, postdoctoral graduate. So I was in a huge laboratory, 19 postdocs, and I was the only graduate student.
This was at the Salk Institute in the 80s. Yeah.
Yeah, and Salk Institute of Molecular Biology and in virology. That was the group. It produced 4 different Nobel laureates. I was working for a guy that had been kind of the lead postdoc for David Baltimore, who was one of the laureates, Indoverma. And so the postdoc that was kind of mentoring me beside the bench, Dan St. Louis, was doing these experiments where he was we could just simplify it and say he had a method for putting gene therapy vectors expressing a foreign protein in a mouse. And he had a problem. The data didn't fit. The protein would be made for about 2 to 3 weeks, and then it would disappear. And so because the other part of the laboratory was working on gene expression and control of gene expression, there was all these fancy theories about how this was getting downregulated at the DNA level and enhancers and all this kind of sophisticated ideas about molecular biology. And I poured through my medical texts because I'd had 2 years of medical school, and I realized that the problem was that the mice were mounting an immune response against the foreign protein. And that's why the foreign protein was going away, is because it was all getting sucked up by the antibodies that were being produced against it. Suddenly, the whole field of gene therapy no longer made sense, because if you give a patient the good gene, cystic fibrosis, transmembrane regulatory protein, or whatever the thing is, but their immune system only knows the bad gene because it's self.
They'll reject it.
It'll reject it, okay? This was absolute heresy because it basically would destroy the whole field. The only way you could do gene therapy is by basically treating people like a transplant recipient and putting them all these heavy drugs, et cetera. And then it just gets really ugly from there.
Even transplants have been known to be rejected because that's somebody
Often
else's
rejected.
DNA, often
Yeah,
rejected. Yeah.
often
That's
rejected.
why, what is it,
So
10, 12 drug therapies for the rest of your
yeah,
life
it's
to
just
keep the heart
horrid.
going? Yeah, it's
And so suddenly the whole logic of gene therapy kind of went right in the trash can.
how did the
And
scientific community respond to those
uh,
ideas about
they
mRNA?
did not like it very much. Um,
What they do, what they say, what they write.
well, it didn't make me popular.
Yeah.
And basically they ignored it until they couldn't anymore.
Wow.
And then they started focusing on things like gene therapy to the retina because the eye is an immunologically privileged compartment, and gave up on curing muscular dystrophy and cystic fibrosis, et cetera, et cetera. Um, uh, but what this led to was, oh, gene therapy isn't going to work. mRNA is a drug. What would you use mRNA as a drug for? And the insight was, oh, you can use it to generate an immune response. You can make lemonade out of lemons. What do you call generating an immune response against a foreign protein? What's the medical terminology? It's called vaccination. Okay. And
Mm-hmm.
so that was the genesis of the whole idea
But
of
it's
both.
isn't it vaccinating to create an immunocompromised response?
No, it's
No, that's not how that works.
no, you want an immune response against a foreign protein. And the foreign protein is typically a viral antigen or a
Which you injected through a vaccine. Not you personally, but
typically, so
yeah.
the way a regular vaccine, so that, vaccines, people act as if there is a vaccine technology. That's BS. There's like
There's a
15 different
hypodermic needle, and that's about it, right?
yeah, there's 15 different vaccine technologies. So live attenuated viruses are one. They're very effective. So this is you take a virus, for instance, or a pathogen, and back in the old days, you wouldn't do GMO genetic engineering on it. You would passage it to make it adapted to, for instance, growth in cell culture, which makes it less adapted to grow in humans.
Like the flu in an egg.
Uh, that's one example. More common would be the live polio vaccine.
Okay.
That's grown in, back in the day, was grown in African green monkey kidney cells. And so it becomes adapted for a different situation. Or another one, modern, is the cold adapted influenza vaccine that we call flu mist. And the reason, so those were cultured, that was a flu virus that was cultured again and again and again uh, under lower temperature than is normally. So instead of 37°C, you back it off to like 34 or something. And most of the viruses don't grow very well, but some of them adapt. And then you get a virus that'll grow at 34, but it won't grow very good at 37. What good is that? Well, your nose is cold. And so, but your lungs are warm. And so you could build this thing through serial passaging
Hmm. And
and sort it into the nose.
where did
And
mRNA play in that universe that
so,
existed before it
so
did?
in terms of, I'm just giving you an example. There's a number of different vaccine technologies.
Yes.
And live attenuated is one, protein based is another, where you grow it. You were talking about chicken eggs. You grow a flu virus in a chicken egg, and then you suck that out. You actually grow it in a chicken embryo, and then you purify the flu virus out of that, and then you purify the proteins out of that. Then you mix it with an adjuvant, put it in a needle, jab. Okay, so that's another kind of traditional vaccine technology. And the idea of using mRNA or DNA as basically using gene therapy tech, because that's what it comes down to. There's a lot of different ways to transfer foreign genes, like adenovirus vectors. Okay? Adenovirus vectors was the other tech being developed at that laboratory I was in at the same time.
That's
Uh,
aerosols.
no, adenovirus is a cold virus.
Oh.
But it was developed as a gene therapy vector, and then it ran into the problems that I was talking about. And um, there was a guy, the senior postdoc in the laboratory, had created that it was developing this tech, had created a company called Crucell, uh, and realized that the gene therapy applications weren't going to work, and that my idea of using gene therapy for vaccines would work. And so that he transformed Crucell into a vaccine company that got sold to Johnson and Johnson. And so the J&J vaccine for COVID
Jansen, yeah.
was directly derived from that other gene therapy platform. So that's another application example. And so the RNA idea was, well, RNA typically only lasts in your body for a short period of time. And I had shown that these synthetic RNAs would last in cells for a few hours. And so the idea was, that really RNA could be used for transient gene therapy. You could administer it, and if there was a problem, you just don't dose it again because it'd go away in a few hours. And otherwise, you would use it like a drug. You would administer it on a cycle, titrating the amount of protein that would be made to the therapeutic endpoint.
Like an Advil that you take until the pain goes away and then you stop.
Well, precisely. I mean, it's the drug metaphor,
Okay.
but using a gene therapy approach. So that was the idea. And the short version is that it worked in mice. We reduced it to practice in 1991 at a company called Vical. And the patents issued and blah, blah, blah.
So this would kind of be like the cure for the common cold, so to speak, at least.
It could be, common cold, it turns out to be complicated. Sorry to make everything complicated.
Well, this
But
is health and science. It is complicated.
one of the causes of the common cold is coronavirus. Rhinovirus is another one. Remember all the fear that we all heard about metapneumovirus, this thing that was circulating in China. That was the fear porn before the bird flu fear porn. And before that it was the monkeypox. The press loves these storylines about how we're all going to die, because everybody reads it. It's
right. The Armageddon comet is on its way. Everybody tune in at 11. Yeah.
Right.
So,
exactly.
Before we get to that, the research you published in 1989, the year I graduated high school, so I'm pretty dumb, with your co-author, I think, Philip Felgner, and
Felgner was,
okay,
yep, and
followed
Inder
by
Verma,
okay,
Inder Verma, which is the head of the lab, and Inder didn't want Phil on that paper.
I'm sure there was a lot of politics behind the scenes.
I insisted that Phil be on the paper, to my everlasting regret.
Oh.
But I was, being a nice guy and trying to be ethical, and Phil had made some important contributions, I thought, and I thought he deserved to be co-author. So that's that, and that one, it got fast-tracked because Inder sent it to a buddy of his at the proceedings at the National Academy of Science. He ended up eventually the editor of PNAS, the Proceedings of National Academy of Science, which has the unfortunate abbreviation of penis. But that's just the way it is.
That's why the injection needles are shaped that way. But so 1990 comes along. John Wolfe and others laid some groundwork for mRNA delivery methods.
Okay, that's a false story.
Okay, tell us.
John had been working for the other big gun in gene therapy, the guy that originally came up with the idea, named Ted Friedman at UC San Diego. So the two main labs in that geographic region along Torrey Pines Road was Inder Verma at the Salk and Ted Friedman at the university and the medical school. And John was working for Ted on retroviral vectors. And John got an appointment at University of Wisconsin. And University of Wisconsin gave him basically, as part of his package, access to rodents and a rodent testing facility, kind of subsidized. And I had interacted with John when he was in Ted's lab. And at Viscal, we needed to find somebody that could cheaply and quickly do animal testing because we didn't have rodent facilities. And so Phil reached out to John, and John's lab was basically offered to inject the animals with the formulations that we were working with. John had heard about what I'd been doing with Ender, and he was excited about it because the retroviral vector business was collapsing, and yet that was his career. So he became the animal testing facility, and I started formulating mixtures and sending them to him to inject into the animals. And there was a chemist that was making some of these positively charged fats at Viscal named Raj Kumar, stridently objected that we weren't doing good science because we weren't using the proper negative controls. And so, because everything I was sending to John was mixtures of these positively charged fats, different versions of them, chemical structures, and the RNA and DNA. And by the way, we were using luciferase, which John had never worked with before, and he was afraid of. I mean, there's a whole lot of things because I was basically bringing a whole different way of approaching all this from what John had been trained at Ted Friedman's lab.
Yeah, like you said in the beginning, you're way out there in a new field where nobody really would believe you
And
or understand
nobody
you.
had ever used luciferase as a in vivo reporter gene before, and you'd done it with statistical rigor. All of that was brand new. The assay that everybody used in the past was chloramphenicol acetyltransferase, which is a radioactive thin layer chromatography method that was messy, hot, just disgusting, and so difficult and expensive that you wouldn't do 10 replicates of it. You would do one and then you would publish it. But that was what John was comfortable with. And so I'd also made chloramphenicol acetyltransferase RNA, not just luciferase RNA. And so I was sending that to John with our formulations. And Raj Kumar said, "You guys aren't doing good science." "Okay, Raj, what do we need to do?" "Well, you need to have better controls." Well, there's merit to that. Yeah, I had tested in cell culture again and again and again, naked RNA, and it did nothing. That's why I went to the positively charged fats. But to basically shut up Raj Kumar, I created a set of samples and formulations in which I included just chloramphenicol acetyltransferase mRNA without anything else, ergo naked RNA, plus various variations on these other formulations.
Does the M stand for, what does the M stand for? Moderated?
Messenger.
Not,
there's
not
different types of
manipulated
RNA.
or
No, there's transfer
manufactured?
RNA,
Okay.
there's transfer RNA, there's ribosomal RNA, there's messenger RNA. RNA gets used for different things by the cell.
Okay, because I know that DNA and RNA have been around forever, but the M part is new, and that's where.
No, it's not new. It's this is fundamental. I didn't invent mRNA. God invented mRNA. It's fundamental to all of us.
Okay.
It's the molecule that transfers the information from the DNA to the protein translation apparatus that makes protein, the ribosome.
Let me shift gears for a second in the nature of time, which I wish I had 3 hours, like a full-on course with you, because I am not a PhD in anything. You were just out talking about the shocking truth that 6 people at the NIH, who built the mRNA vaccine or something around it, they're getting like $100,000 a year for the rest of their lives.
Absolutely.
Do you think royalties are unethical? I think you get royalties, but is that
I
unethical?
used to. I don't have any current patents. And by the way, just to put a stake in that, my total compensation for the patents having to do with mRNA vaccines was one Susan B. Anthony dollar. So I did
No
not
one's going to
get
accuse you of
rich.
getting rich on that. No.
I did not get rich on that invention because I signed away the rights when I went to work for Viscal for $18,000 a year. So there's that. Are royalties unethical? No, royalties are important to compensate people for their intellectual contributions. What is corrupted academe and the government research enterprise is the Bayh-Dole Act. which was done for all the best purposes. The best of intentions often go awry. And the intention here was to incentivize the scientists that are busy doing publicly funded research to protect the intellectual property that they're generating under public funding and get it into industry to fuel industrial growth in the United States. Because basically, pharma and industry in general won't invest in new intellectual property, inventions, discoveries, unless there's a patent there, because otherwise they can invest, $100 million in this or that and advance it. And then the other guy can just come in and do the thing. So this, going back to Ben Franklin and the whole origin of the Patent and Trademark Office. So what happened was under Bayh-Dole in about 1980, so right before all this happened, 80 or 82, was they decided that they would put a structure in place to incentivize universities, government laboratories, and the investigators to disclose and prosecute intellectual property as patents so that it doesn't just go to whoever, go to the Chinese, but rather it can be commercialized and fuel
like
growth
intellectual property protections or
that is
liabilities.
absolutely what this is intellectual property. Okay, this is
Even
how
though
you
it's
do it.
state owned and there's a little
No, it's state funded.
state funded.
Okay, state funded.
There's a
But
difference.
this sets up the situation where the state, ergo our tax dollars, is capitalizing the invention, but then private parties and academic institutions profit from it, as does industry. But then that comes, the logic was, well, industrial growth, jobs, taxes, blah, blah, blah.
Couldn't there be a conflict between those 6 NIH people and the common good if they were trying to push out something that maybe didn't have?
Absolutely. And that's so now fast forward to the present, and the best intentions often go awry, and you see all of the academic R&D complex, as well as the government-funded R&D complex. What we're talking about is the intramural NIH and the Vaccine Research Center, which sits underneath Tony Fauci and the NIAID, which was set up as a government-funded version of Vical, the company that I had been one of the first employees at that created all this tech. So a guy that had been on the board of directors of Vical and a collaborator was appointed to head up the Vaccine Research Center, and the mission was that they were going to create the AIDS vaccine. That never came to pass. And up until this vaccine, which, depending on which side of the fence, it was a success or an enormous failure. But there had been no successes at the Vaccine Research Center after, basically 20 years of whatever money they wanted. So we now have a situation in which virtually all of academic medicine and the NIH is obsessively focused on producing drugs that will lead to, and drug candidates that will lead to patents, that will lead to royalties, that will lead to wealth on the part of, when the royalties come in, they get divvied up. The dean gets his share, the university gets their share, the dean gets his share, the department chair gets his share, and then it trickles down to the individual investigator that had the invention. And so this happens at the NIH too. So the NIH and NIAID in particular has a huge slush fund of patent royalty revenue that is not under congressional authorization. They can use it for whatever the hell they want. And then it trickles down to the individual investigators, and they've capped it at $100,000 per year. They have the right under Bayh-Dole Act to put whatever cap they want on the annual royalties. but this is just one patent that these guys and gals have.
Yeah, 1.2
Um,
million a year for one is not a bad deal. And then you put 10 on there and you got yourself quite a gig.
well, even $100,000 a year is not nothing. Because all of these folks are still out
Is it a year or a
consulting or
month? Is it
otherwise working.
100,000 a month or a year?
Year. Yeah.
Oh yeah, per
So
year. Sorry, per year.
yeah. So
That'll be bad.
they're that this is just a subsidy, and that's they got that coming, that check coming in every Christmas.
Yeah.
Uh, in
Well,
addition to whatever
and for
they
a
generate.
scientist, like you said earlier, you were making 18 grand a year your first gig. I mean, that is a sweetheart deal. And it's like you said, unlimited caps and access to whatever you want.
So that's what has transpired under Bidola, and it's when people are scratching their head about what's happened to academic medicine, uh, at the root of it, among other things, is the Bayh-Dole Act, which was put in, as I said, for all the best purposes, but turns out to have been very misguided and to have really compromised the entire ivory tower structure.
That and the
Because,
Reagan Liability Act, it obviously was.
well, that's the vaccine. So that there's kind of a vaccine cabal of folks that are, the anointed ones in that uh, space. Uh, and we you can see them on CNN.
Yeah, Dr.
Um,
TV, I call him. How do you feel about the evolution of mRNA technology since your initial contributions, and where do you see it heading next? Is it going to be in the food supply? If it
Probably.
is, can we process it or digest it with our liver and kidneys, or will it be the same?
Probably gut. But what's going on? So the Nobel Prize was given for these vaccines, for the COVID vaccines, not for the underlying technology platform, but it was given to Kariko and Weissman. Kariko is a former Hungarian spy. Weissman is a former Tony Fauci postdoc who worked at UPenn and followed my work about a decade later. Katie Carrico actually cites in one of her early papers that, gratitude for my helping her out a little bit. Because she called me when I was an assistant professor and asked, when she was just getting started on this. And I connected her with various people and told her about some of the problems. And what they came up with is what was then emerging new area in mRNA biology, which is this molecule called pseudouridine, which is put into RNA uh, during its manufacturing as a post-transcriptional modification. That means that the RNA comes off of the DNA and then some enzymes make certain modifications to the RNA to add pseudouridines at certain places that are involved in regulating how that RNA, its immunogenicity, its degradation, so it's how long it stays in the cell. And they reasoned that if we put pseudouridine all the way through it, that this would result in an RNA that would be less immunogenic as a foreign molecule and last longer. And it worked. The consequence now is that RNAs, these synthetic RNAs that include pseudouridine in a very unnatural way, behave very differently from natural RNA. And they last in the body for days to months. So now it's acting more like a traditional gene therapy. Follow what I'm saying?
Yep.
Very, very different from the original concept that I was talking about transient gene therapy, and you put it in and it gets degraded really quickly. And if there's a problem, you just don't redose.
Right. From
Now you've got
2 hours, I think I heard you say, to now days, if not years.
months,
Months.
at least months. So that is the tech that is in the BioNTech and the Moderna products. They're licensed from UPenn. And UPenn has made a ton of money on it, plus the cachet of having a Nobel Prize. So UPenn is not an objective player in this space. And now you talk about what's coming on the horizon.
Yeah.
Uh, um, there has been decades of work on self-replicating RNAs, starting off with a group in particular at the Karolinska, where they, give the Nobel Prize. Um, uh, and my first postdoc is Peter Berglund is still working in that area. He thinks that he's got formulations that are much less toxic, but self-replicating RNAs are even further along the spectrum of we don't really know what the dose is, because when we inject something into you, your body is now not only manufacturing the protein, it's also manufacturing more RNA. These are circular RNAs that carry a viral origin of replication and some viral proteins from alpha viruses,
Could
which,
it
by the
ever
way,
get to a point where it was so replicating so quickly that it would actually overwhelm the host? Like it would overflow
the
out of a
good
glass?
news is that the delivery efficiency is so bad that, yeah, it can compromise the cell that it's in. And by the way, those cells all get attacked by your cellular immune system anyhow. But there's so few of them that get it that it's not that much of a problem, except that now these new delivery techniques that they're using are efficient enough that you're getting small numbers of cells all over your body, and that they're getting attacked, and the spike protein is causing other problems, et cetera, et cetera. But
So it could be
looking
like the
forward,
Alien movie where it pops out, you get so much, it just pops out of all your pores and
not we're a long way from that,
okay.
but that doesn't mean that it's we're also a long way from safe.
Well,
Uh,
I asked that because of the misconceptions about mRNA technology. What do you encounter most often, and how would you address those?
so what you're asking is basically a question about the spectrum of adverse events and what's behind them. So, uh, and there's various ways I could talk through about how you can segregate that, but basically the way to think about it is you have the protein that gets made. That's called the payload. So in the case of the COVID vaccines, that's spike. Spike is a very toxic protein. It has a whole host of bad things that it does, particularly when it's expressed all over your body at fairly high levels, higher levels with the RNA vaccines than you see systemically if you get infected by the virus. Okay, and it's being expressed all over your body, not just in your nose or your upper airway. So that causes other problems because it's injected. So you have the payload toxicity. Then you have the toxicity associated with the mRNA itself. So pseudouridine is associated with a variety of its own kinds of toxicities. And then you have the toxicity of the delivery mechanism formulation with and without the RNA. So that's these lipid nanoparticles. And these lipid nanoparticles cross the blood-brain barrier. They do all kinds of things. They have their own intrinsic toxicity. So each one of these components has different spectrums of toxic problems. And in the case of the COVID vaccines, they all come together all in one. So you get a threefer in terms of the spectrum of adverse events.
So it sounds like
And
eating
then
it would be bad, but our gut could probably wipe it out.
eating it, so eating mRNA that, for instance, let's say they're vaccinating chickens, or let's go real world.
Cattle,
They're using this tech in pigs
pigs,
now.
and fish.
Okay. Fish, yes, also. Yeah, fish vaccination is a real problem because if you do aquaculture, you have problems with infectious disease. So if you had residual RNA, would your body degrade it? To the best of my knowledge, the studies with pseudouridine modified RNA have not been done. So I can't say, logic would argue that probably as it passes through the gut, it's going to get degraded. But highly pseudouridine modified RNA behaves differently. So the only way to know that is to do the studies, and the studies aren't being done. because basically the FDA and the USDA kind of go, well, we think it's not going to be a problem, and so therefore it's not a problem.
So 4 years
And
later, we all have third eyes and whatnot. Yeah.
yeah, so that's that this is one of my main bitches is they basically threw the rule book into the trash can. Um, and how they did that was they said, you remember all the propaganda? Oh, this is just standard RNA. I'm sorry, standard vaccines. These are just like any other vaccines. Remember all that propaganda?
Yeah.
And I
And
was
it,
busy
it
saying
lasted 24 hours because they said it stayed in the deltoid, but it never did, not even
and
once.
that was another lie. Um, and they told all of these lies that they actually when the Pfizer data came out, then we knew, oh, Peter Marks actually had the data to know that what he was saying was a lie.
Bastard.
But nevertheless he lied. It's like this Alexander Solzhenitsyn quote that I love. Um, uh, they know they're lying. We know they're lying. They know that we know that they're lying. Blah 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 blah. And yet still they lie.
Yeah.
Um,
Because
and
they
and
can't claw
and
it back from their bank account. If you could go back to your younger self, the one you described in the beginning, and give yourself one piece of advice during those early mRNA research days, what would it be?
hmm, uh, my sin was ambition, and um, that we could talk about why. Um, I had early IQ testing that put me, kind of off scale, and my mother I was expected to get a Nobel Prize. Anything less than that was a failure. I was expected to get an MD. And so, this is a setup. I shouldn't blame my mom. I mean, I was the one that was so ambitious. Uh, um, I would have, frankly, I probably would have been much happier in my life if I'd just become a pediatrician and not tried to change the world and enable gene therapy and all of this stuff. I've probably been way better off and had less debt, and I could have built a nice, comfortable practice in Santa Barbara, and that would have been a different life, more peaceful life, a more centered life, instead of uh, diving into seeking fame, glory, achievement in academic medicine.
Oh, well,
That
God
that
bless you. Thank you for sharing with that. That's powerful right there. And what specific health challenges did you face after you got your own vaccine, and how did they influence your perspective on its safety today?
So I took the jab when it was being given by the National Guard here in our region, and the only one that they were administering was the Moderna product. And I had long COVID, and there was a kind of a promoted narrative that if you took the jab, the extra boost of antigen would kick out your problems with your long COVID. And I needed to travel internationally, and you could not travel if you weren't jabbed. So I accepted the vaccine. I talked to people in the field that were were the ones that, like the group in Canada that originated the tech. They were the ones that should have got the Nobel um, for the delivery, and they told me these stories like it stays put, etc., that turned out to be false. But I respected them. I listened to them. I accepted the product. And in dose number two, I ended up with one of the notorious bad batches. You can look up how bad is my batch and put in
Right?
your batch number. And I got one of the ones that was associated with a lot of sickness and death. And I got a spectrum of damage that at first I could, um, it, these are not things that were in the literature that anyone was talking about really. And I had POTS syndrome, this postural orthostatic hypertension and hypotension. So when you move your body, you would You would have periods of low blood pressure. Probably had myocarditis. Uh, Tinnitus, of course, ringing in the ears, really bad. Uh, Restless leg syndrome, a variety of kind of mild neurologic consequences. Fortunately, I didn't have the really bad stuff that some people get.
Like
Uh,
death.
well, there's death and there's the various coagulopathy problems, stroke,
Mhm.
etc. But um, I I didn't have stamina anymore. The long COVID was bad enough, and then this made it even worse. And not to tell stories, but I had a visit from Mary Holland and Merrill Nass, associated with Children's Health Defense. And Merrill suggested that I really ought to take ivermectin and prescribed it to me. She generally, in the past, hasn't wanted me to talk about that because she was getting her license pulled, but they pulled it anyhow. So I think it's a done deal, and she now has a new life. But uh, it so this true story is that I got the ivermectin prescription, and then I had to go give a talk to the conservatives in Silicon Valley. They have a group. And so we flew out to the West Coast, met my son that lives in Davis, and we went for a hike along Big Sur. And I used to be an avid hiker, a lot of stamina. And I was at day 3 of my ivermectin dose, and I suddenly found myself out hiking my son. And I knew that was like, you know, boing, clearly something had changed. And the ivermectin had really made a big difference in my life, in my stamina.
If it works for parasites, it can work for viruses.
Well, it's complicated. It's not necessarily an antiviral, it's an anti-inflammatory. It has a bunch of different effects. And of course, now people are seeing that it is useful in various cancers. So ivermectin is a natural product, and it wasn't purpose built to cure worms. It just happens to have that effect. And it happens to have a number of other effects too, of which many we don't yet understand.
Yep. And I'm not
But
a doctor, so listen to your own doctor, but I take it on a regular basis just because it's not harmful. So why not? I got time for one last question if you have it.
go.
Okay. So, new Health Secretary Robert F. Kennedy Jr. Unveiled raw data that lays bare the shocking truth behind Big Pharma's vaccine empire. Speaking on a recent podcast, Kennedy laid it bare. The industry pockets a hefty $60 billion annually pushing vaccines, yet that's just the tip of the iceberg. $500 billion of profits on drugs that treat cancer. Do you think a company like, not to speculate, Gilead, focused on cancer cures, that's what they do you think they'd hoard a cure for cancer until we all get turbo cancers and then sell us the antidote for profit?
The ethics of big pharma are very Machiavellian. And um, I'll give you rather than speculate about what they might do or what their motivations might be, I prefer to talk about data or observations. Um, Pharma actively buys up intellectual property that is represents a potential threat to existing products, and basically, using a political metaphor, it pocket vetoes it. So it's normal pharmaceutical industry practice to scoop up stuff that might compromise their existing products and financial interests,
Like
and
monopolistic behavior.
seriously monopolistic behavior, seriously unethical behavior. Um, as a way to preserve their profit margins. So I met once with a Brit. He was actually knighted in London that was working in the genomic space. And he was a cancer specialist. And his big gripe was basically precisely what you just speculated about. That this was a common practice in the pharmaceutical industry to scoop up intellectual property relating to newly discovered genes that could be very useful therapeutically in cancers and diagnostically, and just hoard them and keep them from being available to the public until the patent expired. So based on that anecdote and observation from a knowledgeable person in the industry, I'd have to say yes. Whether Gilead specifically, I don't know about Gilead culture. I never worked for Gilead. There was a number of things during the COVID crisis that they were involved in that was a little distasteful. So, but certainly it is consistent with the general ethics of big pharma, what you just speculated about.
Okay, yeah, and we do know about the Canadian company that had the the founders were found mysteriously murdered in their home. Bunny and her husband, I forget his name, but anyway, that's another story for another day. You are a hero in my mind for exposing this corruption, and we need more people like you to speak out against the entrenched interests that are hurting our society. You know, the old first do no harm, Hippocratic Oath stuff, Nuremberg
Yeah.
Code stuff, but
Medicine is sick.
medicine is sick. And you look like Indiana Jones when he was a hero, but with a beard, which I obviously like. I don't know if everyone's ever told you that before, but every time I see you on TV, I say, that's young Indiana Jones. Dr. Malone, thank you for your time. We are at the end here, so tell everyone where they can go to find out more about you and follow your social media.
So we have a number of websites, rwmalonemd.com, and you can find tons of information there, including my wife's documentation and summary of the events surrounding the mRNA discoveries. The press studiously avoids that, and those documents in their various ways to try to delegitimize me, but they're there and you can read it for yourself. You can also find there, we are the ones that put together the most comprehensive spreadsheet of all World Economic Forum Young Leader graduates. And they're all there in tabbed Excel formats, so you can load it into your favorite Microsoft product and search by country, by industry, by name, blah, blah, blah. So that's a good resource, and so many more things. On social media, it's X, Parler. Please pay attention to Parler. It's back after being killed after J6. So we're kind of one of the ambassadors for Parler now.
And this will be on Play TV, by the way, which is owned by Parler. That's one of our video platforms. So be sure to alert you here. Yeah.
Thank you. Yeah. So Parler is being very kind to us and helping, spoon feeding me how to work with a Parler platform, and also Truth Social and Getter. I no longer post on Gab because there was just too much anti-Semitism, and I just
And you were one of the early cancels on Twitter, I guess. Yeah, Twitter 1.0.
Yeah, back and so 2 days before the infamous Joe Rogan episode that generated such an outroar.
Yeah, not just infamous, famous. It was his biggest show ever. Yeah.
Until Bobby, and Trump. So X, Parler, Gab, Getter, and Truth Social, it's at RW Malone MD. And yes, I was permanently deplatformed from LinkedIn at precisely the same time that I was permanently deplatformed from Twitter until Elon came in and the Twitter files and suddenly I got repatriated. So there's
Unbelievable.
that. And then the thing that sustains us is something that Steve Kirsch told me long before even the Rogan hit that I should get on, which is this thing called Substack. And we publish daily on Substack. My wife was just in here bringing me a cup of coffee because she wants me to review her Substack for today. And you can subscribe to our Substack, which is now titled Malone.news. And it'll come into your email inbox on a daily basis. And you don't have to pay, but if you do wish to subscribe annually or monthly, it's what sustains us. It's only a tiny fraction of our total user base. We actually have about between 300,000 and 500,000 views a day on
That's
our
great.
Substack essays.
And I want to thank you
Which-
personally because 4 years ago, when I first took over my newspaper, you kindly let me republish one of your op-eds in my little hometown newspaper back when nobody else was listening to the truth. So
Cool.
you let me publish your truth because I'm a truther in our little paper. So thank you. Mill Creek View is what that was called in Seattle.
Excellent. So yes, Seattle, boy, you were in the heart of it.
Yeah.
The
Heart of
only
darkness.
thing you could have been in Portland, it would have been worse, but not by much.
My office was 35 minutes away from Kirkland, Washington, which was they call ground zero. So yeah, it was interesting times.
My family used to live in Kirkland.
There you go.
Dad worked on the 747.
Boeing. Okay. Yeah. Yeah. No, I was there in Bellevue before it had high rises. And that was where the little nursing home in Kirkland started it all. It was right before Valentine's Day on a Friday. So I went home Thursday thinking this will pass and didn't go back to the office for 2 years. But I got to listen to you because even though Twitter canceled you, which I wasn't even on at the time, I knew that there was people like you and McCullough and across the border there, Ryan Cole, Dr. Tenpenny, some people who are willing to say at
Byron
great
Bridle.
expense the
Don't
truth.
forget Byron Bridle up in Canada.
Dr. Atlas, yeah.
Yep. Yeah, Scott Atlas, who's back. So those are the points of contact, and of course you can buy the books you kindly mentioned, including Cywar is the current one that I'm trying to get people to read so that they understand what's being done to them and can be basically immunized against it.
It's going to make a great movie too.
Ha! Well, I'm not going to hold my breath on that.
Right.
Yeah.
I can find you a director. But thanks again for coming on with us. Everybody, hold on. I'll be right back.
Sing a song about the heartland, the only place I feel at home. Sing about the way a good man works until the daylight's gone.
Thanks for coming back. It's time to remind everyone to please subscribe to heartlandjournal.com. That's how we grow and keep this content free for you. That is it for this episode. Thank you, Dr. Malone, for saving my life and my family's life, for cutting through the trillions of dollars of propaganda spent on TV to crowd you out and sell us unsafe and ineffective medicines for profit, not health and science. I knew when you got canceled that you were over the target and were probably telling the truth, and that's why I let you be into my newspaper, and that's why I'm so thrilled that you accepted my invitation to come on my show. You are a savior, even though, like you said, you regret your invention like Dr. Frankenstein did, but you're doing your best to get everybody to pay attention to something that does work, like ivermectin. Allegedly, I don't even know. This is goodbye for now. I'm your host, Steve Abramowitz, editor-in-chief of heartlandjournal.com. See you all next time. Peace in our time, and definitely glory to God, and God bless Dr. Malone.
Yeah, I've been dreaming of the wild, wild plains, walking where the pine trees dance.
Heartland Journal Podcast is the media property of heartlandjournal.com, where you can find news stories, commentary, and content serving the heartland of America. Any views or opinions represented on the podcast are personal and belong solely to the creator and do not represent those of the people, institutions, or organizations that the creator may or may not be associated with in professional or personal capacity unless explicitly stated.